Thank you all for waiting. The workshop will begin shortly. Thank you all for waiting. And welcome everyone to the ninth M4DT Day with the topic Digital Calibration Certificate. My name is Aldo Garcia, and I'm a metrologist at Senam from Mexico. I currently lead one of the digital transformation task forces under the name of Agile Projects, and today I will be the host for this event. Before the start, it's important for you to know some specific guidelines. First of all, the event will be recorded from the beginning until the end. Please, your microphone and cameras must be turned off unless you are asked specifically otherwise. You can use the chat to ask any question to the speaker at any time, but they will answer as soon as the speaker ends the presentation. Right after the end of the event, a short poll about today's experiences will appear. Please, it will take a little time, but for us it's important feedback to improve our work and next events. This workshop is organized by Metrology Working Group number 14 of the Inter-American Metrology System, and our objective with these events is to promote the digital transformation in the region and make liaison with similar organizations. The Metrology Working Group is the link between SIM Metrology Working Groups and the digital transformation. The Metrology Working Group number 14 has 6 task forces to specifically work in subjects that interest the region. I invite you to participate in all of them. The contact of the groups will be shown in the chat box. Also, I would like you to check our website where you may find information of the task forces, activities, and other events. Also, you may find videos and several presentations. The web page will also appear in the chat. So please, I ask you for check the chat, please, and watch all this information. Thank you. I now give the floor to Mr. Carlos Galvan to give the welcome and opening remarks for the day. Carlos works at the Senam, Mexico in the Directorate of Dimensional Metrology as responsible for the IT activities of the directorate, the development of software for measuring instruments, the development of new algorithms for control and measurement development. Currently, he is also coordinator of the calibration services of the directorate and actually is the coordinator for the Task Force Digital Calibration Certificate. Welcome, Carlos. Please go ahead.
Thank you very much, Aldo, for this nice introduction, and welcome everyone to this M4DT Day for Digital Calibration Certificates seminar. Today, we are going to have two talks with two excellent speakers, Daniel and Federico. I really appreciate your collaboration in this effort in the SIM region to disseminate all the information about the digital transformation, in this case, specifically for DCC. Thank you very much, Federico and Daniel. Before the presentations of our invited speakers, I would like to introduce some material about what is the Digital Calibration Task Force in the SIM region. Sorry, I don't know if you see my screen right now. Please confirm.
Yes, we can see it.
Thank you, Aldo, thank you. So the Digital Calibration Certificates Force has the main objective of exchange information about DCC and implementation in the SIM NMIs. Actually, we are working 15 NMIs with 25 participants from these NMIs around the region. Was established in the last year, in August the last year, and until now we already have 3 main meetings to discuss these topics about the DCC. The next meeting will be on November 28 at 15 UTC. So if you want to participate, please send me an email and I will include your names and your names in the team, and we will work together about the DCC topic. Analysis of the DCC structure, discussion of the different approach for get detailized data, and different uses of the DCC in the future. So I think that is a very interesting topics that we already covered. Until now, we are going to start with the participation of different NMIs to show us how they are doing the work on the DCC projects. So what activities are ongoing until now? So the discussion about calibration certificate developments and different NMIs. Actually, we are working on a surveys to identify the digitalization data infrastructure for the different NMIs in the region. And we are working to define a list of NMIs interested in development of DCC inside the organizations. Also, we are working on the working plan for the 2022 year. So please, if you have interest in this interesting topic, please join us. Please send an email and we will in touch. So I will give the floor to Aldo and continue to the talk, and welcome everyone to this M4DT Day. Thank you.
Thank you, Carlos. We will be starting with the first presentation of the digital of the day, and this is SI-based digital data formats in metrology. The presentation will be in charge of Daniel Hutzschenreuter of the PTB Germany. Daniel Hutzschenreuter has been a member of the PTB in Germany since 2015. His field of work is focused on the online validation of computational extensive evaluation algorithms and the development of universal data models for the digital transformation in metrology. On the international level, Daniel is actively supporting the Euramet TCIM Working Group Metrology for Digital Transformation and the CIPM Task Group on the Digital SI. Welcome, Daniel. Please go ahead with your presentation.
Okay, thank you very much for the nice welcome words. I will now start to share my screen. Okay.
Yes. Okay.
Seems to work. So thank you again, especially to the organizers of this workshop for the invitation. Today, I like to speak about some background to the SI-based digital data formats in metrology, based and give an insight to findings from the MPS project Modcom and projects beyond. It was already mentioned. There's the CIPM working group also working on a digital SI. So for the background or the overview of my talk, so it will be a major part about the so-called DSI metadata model that was defined in the European project Modcom. So I'm speaking here in the role of being a member from that project that now ended after 3 years. And at the end of my talk, I give more insights about the work of the task group at the CIPM that is representing the Digital SI initiative. And here I speak in the role of the convener of the expert group that is making technical recommendations towards CIPM. Okay. So the MPS Modcom project started in 2018 with several partners from European metrology, universities, and also companies from different domains. Like length measurement, pharmacy, and weighing industries, with the vision to establish first ideas for unambiguous, universal, safe, and uniform communication and exchange of general meteorological data in domains like cyber-physical systems or the Internet of Things or applications in the domain of Industry 4.0, where you have measurement devices, sensors connected through networks and exchanging digital data that is containing measurement data. The aim was to develop these principles for communication and validation of smart data in these IoT networks, whereby communication addresses the unambiguous, universal, safe, secure, and long-term readable development of data models and formats that are suitable to provide measurement data. And also first ideas for digital calibration certificates were part of that project. The validation considered tools that could be used by humans and machine to validate data, to check its consistency and contents. Smart data in the project considers not only raw data that is put on databases, but we think of digital information that is formatted in a way that is usable for further, so for example, advanced data consolidation and analytics that is not only done by humans, but in particular by machines, by software. And of course, IoT networks, we speak of digital networks of sensors, like in the domain of smart sensors, smart homes and Industry 4.0 and smart cities. And today I will only focus on the first part, the communication, and present to you the core data models for measurement data called the Digital System of Units Metadata Model, or in short, DSI. So, and I will start with the analog data that we can find today, for example, here in a PTB calibration certificate. And what you can see today, our ways of reporting measurement data have grown historically, and even in a human readable document, the data is provided in a way that seems to be compact and good for humans. But you can see on basic questions, how are units, values, and uncertainties presented? There's a huge difference even in one document. Going from different ways to align units, values with units, up to different ways to report the uncertainties. And we can say today in the analog world, our way of reporting data is far away from uniformity that we would need for digital data exchange with machines. When we look at existing data formats and exchange formats, you will see that there are hundreds, if not thousands, formats are out there in the world, all developed for different domains like E-class in the automotive sector. You have formats for reporting units and quantities. You have formats for data like calibration and so on. And also, sorry? Pardon?
Go ahead, Daniel. Please turn off your microphones. Go ahead, Daniel. Thank you.
Okay. Good. Okay, sorry. So you have all kinds of formats in the world. If you look at them, you will see that they are all not really interoperable. They have been developed for different domains, not considering a broader interoperability of data, for example, or few of them. And you have like a biblic chaos of different languages. And for digital future, basically nobody is able to understand the other side. And the vision of the Modcom project is to install fundamental principles that are international agreed from the International System of Units, the vocabulary in metrology, and the guide to the expression in uncertainty in new data models, the DSI, as a common language on which all organizations in the world can rely in future for the digital data exchange. So why is there a need for such a common format, and why is there in particular a need for the International System of Units to be considered carefully in the digital communication? So today, different users in the world have their typical user interfaces, computers, laptops, files, where they exchange all kind of individual data. Like you have metric units, you have imperial and customary units. On the other hand, you have numbers encoded in decimal formats or binary. And of course, you have worldwide a lot of different languages that humans speak. In future, the aim is that such data, of course, is exchanged between machines, between software and computers. And of course, for them, it's hard to really understand these different ways how humans communicate. So here, universal, unambiguous, safe, and really easy to understand protocols for the data exchange are needed. And of course, the motivation for using DSI is that it's the really simple and globally agreed system of units that should be considered in the view of Modcom here at the first place for establishing machine interfaces with metrological data. That is not only usable for digital calibration certificates, but for all kinds of data in different formats. And that is also suitable for smart machines in future to be used and understood very easily. So the principles for the development are outlined here. So the idea was not to really invent the wheel again, but to look at existing standard and guidelines from metrology and information and computation technology, like the SI brochure WIM and GUM, but also like the ISO 80000 series, the International System of Quantities, or standards like ISO 8601 for time statements, IEEE 754 for numbers, and so on. And based on that, to consider what of the standards is needed to establish the metrological data exchange. Now it's working. So now the information from the standard was used and put into consideration, saying what is the minimum required information for machines that makes the data that is needed to be exchanged universal, unambiguous, safe, and easy to understand. So the process here behind us today, we have the human-to-human communication considered in these documents to a good part in metrology. So the Modcom project tried to think what will be the needed change of the data to make it suitable also for the machine-to-machine communication, and of course also to machine-to-human and human-to-machine communication. And what came out is the so-called DSI metadata model that is documented and providing basic data elements, universal data elements for all kinds of quantities. And its application is considering basic data exchange, where we exchange, for example, single values in different formats like XML, JSON, binary with digital measurement devices, interfaces. But then it could also be used or should be able to be used in advanced formats. For example, the Digital Calibration Certificate is an advanced format that is containing much more information than the core terms for measurement. Also, research data formats could be considered here, databases in general, or even applications for interfaces of new technologies like digital twins. And from this whole diversity of the potential applications of such a universal data model, it's clear to make it work. In general, the initial core terms must be as simple as possible to be usable with many different domains. So here's an outline what is then under this philosophy contained in the DSI data model. So to make it universal, we thought of atoms, so the smallest parts that could establish universal metrological data. And these are real quantities, constants, quantity values, complex quantities, and vectors that you can find in the WIM and the GUM. Here called in the DSI with the prefix SI always as SI real, constant, complex, or list and complex list. And then based on the atoms, there are extended models introducing models for measurement uncertainty, like you have the univariate uncertainty in the form of expanded measurement uncertainty or coverage intervals. and for example, multivariate uncertainty in the form of covariance matrices, coverage regions. And there are also generic structures allowing you to combine these atoms and extended elements in the form of general lists. And there's also an adapter to consider how to use non-SI units with the SI units. And it was developed for the use with physical quantities. So the current development status is that it's not containing reference procedures or reference materials. So more about the philosophy. So thinking what makes data usable for machines is expressed here. So today in the analog data, we have many options how to present units. And we say a SmartCom idea is to say in 30 years from now, when we speak maybe of a digital future, we need much simpler interfaces and data protocols than we use it today. So the big vision is to say in future machines in the best case use units only based on SI base units and some units like 1 or hour that have an important role in many data. And to stepwise go away from non-SI units. This change is for the digital world. It's not considering that humans drop their used units in the near future or anyway. So the human readable data representation is not considered to be changed by this SmartCom proposal. In addition to the classification of the units, there are more concepts that were considered when developing the DSI. To make it really easy for machines to be reused. So today in the data, we have many different options how to present one and the same information for a quantity and uncertainty. The high diversity is hard to interoperate today already. So for the machines in the future, it's aimed in SmartCom to have a very small set of variants supporting at the same time all the necessary functions that you need from the data. Then a topic is redundancy. Today, redundancy gets problematic when there is redundant information that is inconsistent and leading, for example, to different conclusions based on data. One example, sometimes there are many discussions about the outcome of key comparison studies. And for the DSI, it's also the mission to reduce, where possible, redundancies and to really have one clear interpretation of the data. And finally, also important for the digital formats is the arithmetic topic. So today, the data, the diversity will need a lot of conversion between different representations, numbers, and uncertainties. All of them are introducing, even if they are small arithmetic errors. And by reducing variance and redundancy in the DSI, it's aimed to also follow the principle to reduce the need of conversations and to have data that could be used with really few additional computations on the side that is receiving the data. Okay, so now how does it look in practical for real quantities? Today you have the value and the unit. This is the minimum requirement in SmartCom to provide this. And then you have a lot of additional information about the uncertainty and even information on the time when a measurement was made, which is important for some material measurements. And in the SmartCom, it was defined the real quantity in the atomic form to have really this numerical value and the unit as mandatory elements. And in addition, you have a label and the date time. Thereby, the value is at the moment based on the IEEE 754 format for double precision numbers. It should have the dot as a separator. It allows scientific notation, and also the DSI considers some critical statements like there should be not a value like not a number or infinity. The units are based on the 9th edition of the DSI brochure. They should be an encoding is provided, suggested based on the LaTeX package SI unit X, but it's not the complete package. It's only a subset that is again presenting an unambiguous, non-redundant, and minimal set of the unit encoding that is sufficient to provide all SI units that are possible. Datetime is based on the UTC standard from ISO, and the label is based on UTF-8 encoded text, for example, for providing a kind of quantity that is underpinning to the real quantity. And finally, just a comment, the real type is a general data model, and when it comes to particular implementations like XML, then there's the general recommendation to follow to UTF-8 encoding, but then also additional requirements from encoding in XML must be considered. For example, you shouldn't add text in XML that is not valid according to the XML syntax. Just a glimpse onto the units. So today the BIPM SI brochure is defining the international system of units. It has three main components. One is the base units and derived coherent units with own symbols. They can be extended with SI prefixes to create multiples and submultiples, and with adding exponents and multiplication of many units, you can create all kinds of physical units that are used in practice today. And this is implemented in the SI Unit X encoding, and the DSI considers, of course, further rules on units from the IC technical specification that is mentioned here, that is defining allowed combination of prefixes and units. So just one remark, sometimes in discussions it's said DSI is ambiguous regarding candela or the unit of centiday. And the truth is, no, it's not unambiguous. There's a clear rule in DSI saying a centiday is not allowed as a unit, this combination of centi with day. Yeah, then we have the extended data models with the uncertainty, with the expanded uncertainty and coverage intervals that add to the atomic types. And in this case, the guide to the expression of uncertainty is the basis. And here in the example of the expanded measurement uncertainty, it's encoded the uncertainty value based on the SI value, on IEEE values, and it's providing the absolute value of the expanded uncertainty. The coverage factor is a value greater or equal to 1, and the coverage probability is provided as mathematical value, a value between 0 and 1. And there's an optional element to also provide an information on the statistical distribution of the quantity that is not further regulated at the moment by the DSI. And here a full XML example. So you can see the main element as a real, and as a sub-element, it has the label, value, unit, and date time and the respective encodings. And similar, the expanded uncertainty is provided as a sub-element with the components of the expanded uncertainty. Another example, the hybrid type, I mentioned it at the beginning. So the suggestion of the DSI is to say, yes, it's possible to provide any non-SI unit in the DSI, but the rule is to provide it together with the same quantity value converted to an SI unit. So you can see here, it's possible in the DSI to exchange a length in feet, for example, a US unit. But then the value has also to be provided within this hybrid adapter in the SI unit meter. And regarding the classification, units that have a lower classification for the use with machines, when they are provided with this hybrid adapter, could also get a gold classification for good use with machines. Then I'd like to show you some examples of the application of the DSI. And the first example is the use of the DSI in the high-level structure like the DCC. Here, this is the picture of the Digital Calibration Certificate format that was developed in Modcom and at PDB now by the GemiMac project. It has the different shells of data, and the DSI is used in the shell with the results of the calibration. especially for providing really the quantities that are the outcomes and input of calibration measurements. Here's an XML example outlining what's the difference between the DSI quantity and the DCC quantity. So the DCC defines an element that is called quantity, and at its core, it contains a SI real element from the DSI metadata model, providing the actual measurement information. And the DCC as a high-level structure is adding to that core information all calibration and human readable specific data, like the name of the quantity in different languages, and also additional metadata about the provenance or settings of machines, of measuring devices, and so on. So the DSI was never meant to be the big data monolith containing all this information, but is meant to be integrated as a core of information in many different data formats in the future. Another example that was worked on in the Modcom project is a machine-readable list of the constants, physical constants that define the SI units. And so also the DSI is capable to provide constants in a general way. It's providing a concept also for encoding rounding errors of constants as uncertainties where it is necessary. At this point, I like to come back to the point where goes the development beyond what Modcom has done. So the Modcom DSI is a starting point, and it's today majorly used in the DCC XML format. And it's subject to maintenance and by PTB, so potential changes that could come in the future and are updates of DSI. But we also consider feedback from international organizations like the CIPM and DCC developments and international agreements, as well as additions regarding reference materials and procedures. And the red marked aspects, feedback from the CIPM and international agreement is here very important. So in 2019, the CIPM has founded a new task group and expert group on the digital SI. Here you can see its members. It's a group that's now working worldwide with support of NMIs and many organizations. And this group has brought forward already a greater vision for the international metrology that's called the so-called SI digital framework. So it's the aim to go for international, worldwide agreed, uniform, ambitious data exchange framework now that is based on the SI. Which will in the future consist not only of SI core elements, but also of software and tools to allow certain services and broader applications with the SI elements in the future. And so for the DSI, it means that this international core representations and developments are the candidates to in the future replace elements in the DSI, or to completely even replace the DSI, or to have the DSI adapt elements from the international recommendations. And in addition to the DSI, the international work will add more services and tools, and also go stronger in the direction of data being ready for analysis, for example, by AI and fair data. Yes, finally, the international activity of the CIPM is not only addressing the metrology world, but it's working together with also scientific communities and all organizations in the quality infrastructure, because the international system of units and traceability is a joint work of standardization, accreditation, metrology institutes, and so on. And yeah, if you look at data there, then it's clear calibration data is not only about the core information here in red, but there's a lot of more contextual information that will be needed in digital formats. And here the DSI digital framework will in future help to establish global common formats for quantities. At this point, I like to come to the end. I thank you for listening. And if you want to know more about this Modcom DSI, you can go to our Git repository with documentation and XML examples, or visit this Modcom website. And if you are interested in some first informations about the CIPM activities, I'd like to invite you to go to the website of the task group or the workshop that was held in February this year about this topic that you can find at the BIPM webpage. With this, thank you, and I'm looking forward to your questions.
Thank you, Daniel, for your participation. And we are going to go with the round questions. So we have a few. Francisco from Senam asked, do you consider that by saving the minimum of information when they're recording a measurement, it is possible efficiently to make representation of this measurement in different environments? Is this a challenge to digitally represent the units of measure? I hope I read it well.
Okay. I hope I got the question right. So this question of minimal representations, minimal requirements, I think it's a general question that also the representation of units should address. So in the end, we are aiming for interoperability of data that is established by machines. And one way to get there is to make data much more easy, much more general, to have less options for machines to interoperate it. Other ways are writing converters between formats, which is much more expensive, needing much more software development probably in the future. So it's my opinion, the opinion from Smart.com, that it's essential to really develop interfaces and data models that are as simple as possible at the bottom of formats to make it really usable to many domains.
Perfect. Thank you.
Maybe I can add something to that. Recently, I had a discussion with a colleague from PDB who is working in the implementation of digital calibration certificates. And he was telling me, yes, it's a lot of difficult work when the DCC parts are discussed. And he's always happy when it comes to the DSI, because there it's very clear what is to be written into the data and how it is written. So it shouldn't be underestimated how complex data structures could be difficult to handle in the future. Okay.
Okay, understood. Thank you. There is another question from Francisco too. What are the main challenges you have found to implement the DSI in measurement laboratories?
Okay, so adding to the question before, the DSI is very compact and very minimalistic. So the main challenge is really to first describe and make people understand what was the motivation between the DSI, why was it designed for machines, and in particular, explaining why it's not providing all kinds of measurement representations. So a common question is, can I provide a relative uncertainty? A common question is, can I provide a standard uncertainty? So the DSI here decided for only one representation. And I think it's an interesting question also for the CIPM and the international development to see in future, is this way really the good way, or will there be maybe a different way that's better for a bigger community outside Europe, for example?
Okay. There is another comment about Francisco, and he says, I suppose that some attendees still don't know the DSI document. Could you tell us how to find the latest version on internet?
Okay. Yes, so I can give you I think the presentation here is provided maybe to everybody in the end, but I can also give you the link. So this document is provided with a DOI number, so you can simply find it by URL on Zenodo. It's public, it's free. Okay.
Okay. Thank you. Thank you.
Yeah, and the detailed links are hidden behind these blue lines here on the last slide.
Thank you very much. There is a question for my side. Do you think these digital calibration certificates will be used at the smart cities with massive sensors? I don't know if I. Okay, go ahead. Thank you.
Yes, and I think it's a general question about smart sensors. I would say in future, a smart sensor should be able to access the information of its calibration or conformity assessment if it's available. And the digital calibration certificate could be the container to provide this data to a sensor. And more and more measurement devices also have a little memory for storing data. So maybe in future also DCCs are directly saved with the devices.
Okay. Thank you very much. There is a comment and I think a question from Federico Grasso. From everything published before you about the SmartCom, you use to describe your XML
okay,
format.
Sorry, somebody is talking in parallel.
Se lo presenta el director y poder cumplir la meta.
Pardon, can you please repeat the question?
Yes, sorry. From everything published before about the SmartCom, you use to describe your XML format as a DSI data model, but starting in this presentation, you are calling a DSI metadata model. What has changed in these last few months of SmartCom to make that change in the model? And what does it mean? Thank you.
Okay. Yeah, sorry. It is because I'm sometimes careless saying data model and sometimes saying metadata model. If you look in the DSI brochure, then it will always say metadata model.
Daniel, I just checked in Zenodo. It says data model in Zenodo.
Okay.
That's what I'm asking.
Good. So the question, what's in the end the difference between the data model and the metadata model?
Okay, so but what does a metadata model means?
Yeah, so a metadata model in this sense means we have the data like the measurement value and also metadata like the unit, a timestamp, and so on.
So then you mean
I'm using it many times in the same
metadata.
sense. Yeah, I'm
so
using
it's information model that includes data and metadata. Sorry, can you hear me?
Yes.
So what you mean is information model that includes the data model as you describe DSI and the metadata model as you shown in the example from additional information describing the result. Is that what you mean?
I'm not sure if I got the question right.
And
I just wanted to say that I use the word data model and metadata model in general and common sense.
Okay. I just for if this were machine to machine, the machine would be confused because there are two different models. One is data model and metadata model. That's why I would like to understand the difference.
Okay.
Thank you. I'll send you. I think you meant an information model based on data module and metadata module, and I think in your example it's perfectly proven what the DSI part of the DCC is. One part focusing on the data and the other part focusing on the metadata. So I think it's clear, but and this is the problem that we're going to have with interoperability. We need to be clear about the terminology about it.
But if you look today, then many terms are used, even terms data formats and so on. So I think in the end, you are right. Yes, finding the international definitions for these terms is still in the metrology world not clear, and everybody is using it in individual ways.
That's why the next step is the DVIM, right?
Well, I think this is it another question?
Yes, sorry.
Okay.
Thank you both. And I don't know if you want to continue with these comments. There are another questions. I don't know, Daniel, if you want to continue answering these questions.
Yes, if you have more questions, I'm happy to continue.
Yeah, only to be sure that we can give the time. Okay, Enrique Gaitan asked, which will be the role of the accreditation organism in the development of the DCC?
Mm-hmm. Okay. I think one question that accreditation has at the moment is, what is a DCC? How does it work? And probably what will it mean for the processes at calibration that are accredited? So the role of them could be to start getting informed what DCC are, start engaging in projects to understand the developments, to add the needs of accreditation to that development. So in the end of the day, for the end user, it must be made sure that a digital calibration certificate is treated in the same way by accreditation as analog certificate. And this is, I think, considering accreditation as well as quality management in that sense too.
Okay. Okay. There is another question from Chris Paredes. In the DSI framework, there will be room for transmitting information about method-defined measurements and does not hold in plain the SI-related units.
Okay, so method-defined measurements, I would think it means quantities that are based on reference procedures, I guess. Yes, it has not been added to the DSI so far because we started the development with the physical quantities to be not too broad in the project. So it was already a lot of discussion in Modcom how to implement the physical quantities. But yes, for the future, it's foreseen to add also the information about procedures as a reference for quantities in the DSI. But probably CIPM is faster to make suggestions in that direction.
Okay.
That we then adapt maybe in the DSI in the future. But it's right, we had discussions, procedures like hardness measurements with the Rockwell scale. This to do in the DSI. And of course, the DSI is not complete. It's the first initial work into that direction.
Okay, it's important to understand that we're still working. Okay, from Gabriel Spam. Hi, thank you for your presentation. Do you think that it's possible to make data mining of data formats and this new standard base in XML?
Okay, so data mining is now a topic going into the direction of big data. So independent of the format, I think data mining procedures are somehow applied on databases with data sets. The DSI is not limited to XML. So probably it could also be implemented in databases and other formats like JSON. And at the moment, I see no problem in applying data mining to that. I mean, today data mining is applied to much less complicated metadata where you only have values but no units, for example.
Okay, thank you very much. We thanks Daniel for his presentation and for answering every question.
Okay, thank you as well.
Now we are continuing with the presentation and the next speaker, Federico Grasso Toro from Metas, Switzerland. The name of the presentation is Overview of PDF A3 Solution for Digital Calibration Certificates. Dr. Federico Grasso Toro has an electronics engineer degree from the Universidad Nacional de San Juan, Argentina, at 2010, and a PhD in mechanical engineering from the TU Braunschweig with the topic the IA for GNSS-based localization systems from Germany. In metrology, he worked on legal metrology for PTV in Berlin and revising regulations such as WELMEC Guide 7.2 and OIL-ML Document 31 for software requirements for measuring instruments. Since 2019, he is the project leader for the digitalization projects in Metas, Switzerland. Welcome, Mr. Federico Grasso. Go ahead with your presentation.
Hello, everyone. Can you see my presentation and hear me?
Yes, we can.
Yes?
Yes.
Okay, good. Can you see my cursor, everything? So as described already, the long title of this presentation is towards the digitization of calibration certificates, a short overview of PDFA level 3 solution for digital calibration certificates. So the general agenda for today is I'll repeat, because I repeat them every time that I present something, a few of the digitalization concepts in themselves. And after that, of course, I would focus on how have we been dealing with this in Metas from the point of view of common requirements to develop DCC. So the important thing is what Daniel has been presenting is the topic from the point of view of DSI or units. We're not talking about that. We're talking about the transitional period between right now we have paper certificates or paperless certificates towards digitization. We need to prepare a lot of things. And for those preparations, we'll be focusing on common requirements that we will discuss. And then afterwards, I'll show a couple of examples. And then, of course, a few points to continue the conversation. So firstly, and I repeat this every time, so if people have seen this, sorry. If people are new, welcome to the explanation between the difference between digitization and digitalization. Digitization is basically to scan a map. So if you digitalize a map and you scan it, that's not exactly Google Maps. So to digitalize a map would be to create a service such as the already well-known Google Maps. So what we're trying to do with digital certificates is digitalization of digital certificates. So we don't want just to do paperless certificates. We want to do paperless certificates that provide additional services, such as Google Maps provides additional services. So the two big points here for digitalization is to create new markets, so the new services, by means of new digital technologies, and not only basically making paperless already existing services. So I hope that is clear. I keep repeating it because it's important for us to have a common base ground. And then from there, we can focus on what would it mean to digitalize, not digitize, digitalize a calibration certificate. And for that, in Euramet, we have a project as part of TCIM 1448 that is focusing on the development of digital calibration certificates in an NMI level. For that, we've been discussing something that we've been calling the common requirements of DCCs. So here I make a list so everyone knows when we describe a DCC, what do we mean as a common requirement? In the same way that ISO 17025 describe common requirements for an actual certificate in a laboratory, or a report in a laboratory, this is what we have as a list of common requirements for a DCC. So the first one is, and this one has been just added because we were assuming that it was obvious, but it makes no sense to not consider it as part of actual requirements, so we put it in. The first requirement is the DCC must be useful for long-term archiving because that's what a certificate actually is expected to have. The second one, and here we start with this digital technologies allowing us to have additional services just with a certificate, is that the DCC must be machine readable. And machine readable brings all these new beautiful functions, but at the same time, all these beautiful problems that Daniel has been showing in the previous presentation. So machine readable in the level of complexity of how the machine-to-machine communication might happen is something that is still open, but we consider it a minimum common requirement for a DCC. The third one is, of course, if it's a calibration certificate, the digital version of it must also be traceable directly or indirectly to national standards. Basically, that is, it is still a certificate. It's not a second thing that comes from the certificate, and it's not something that can develop a certificate. It is a certificate in itself. So the fourth requirement would be must constitute proof of metrological traceability. All of this, just 3 and 4, means that this digital document has to have the same properties that the paper that we used to have, just as a calibration certificate. The fifth one, and this is the important, is marked may, because it is not must, it's may. It's an opportunity of developing these new services based on digital technologies. We're saying that a DCC may include additional information. And for us, additional information might be the data and or metadata, so description, data about data. Examples given of that would be, for example, the numerical calibration curves that NMIs produce but don't always share with the customers because they're just not the end product, or any other additional calibration evaluation information that might end up being useful for the extended options of the user. For this, don't worry, in a couple of slides, I'll give you a specific example of something that we're already doing in Switzerland. And then the sixth one is, now that it's a digital document, we need to focus on the IT security aspects of it. So for that, we have said that a common requirement, a sixth common requirement would be that the DCC must use some kind of cryptographic signature as a security procedure, basically guaranteeing the 3 minimum characteristics of IT security, meaning integrity, authenticity, and if needed, because this depends always on who's using the certificate for what, confidentiality. So that's it. This is, as I said, an ongoing discussion in TCI M448. So this started in January 2020 in a meeting that we have in Bern. And then, for example, this added requirement regarding the usefulness for long-term archiving was just added this month. So you see, this is not a fixed on stone thing. This is something still evolving. But why we're doing this is because we're always trying to focus on a general enough description of requirements that would cover certificates in any kind or any type of field in metrology. So regarding that, as I said, is the beautiful problem of machine readability. It breaks down to what does machine readable means. So here's I made a slide, frequently asked questions regarding machine readability, that I hope helps everyone understand what we're trying to work with. So basically, machine readability would mean that data can be processed by computers without any human interaction required. That's it. Meaning that interpretability or actionability based on that, that's different layers or different complexities of this machine readability. But basically, in order to have machine readability, and now I'm repeating what Daniel said in the previous presentation, is we need to aim for interoperability. And that's the most important thing. Now, examples of machine readable data formats that already exist, for example, XML, that is already been worked on within Microsoft, or example of RSS for web feeds. Or JSON, also mentioned, usually used for transmitting data within web applications. And last but not least, and I'm using this example because it's part of one of the examples of the digital certificates that we already provide in Metas, is a VNA file. VNA, vector network analysis, is one of the typical measurements that we do and that people all around the world provides by the means of a tool called VNA Tools software that has been developed and used in Metas. So that's a specific file format designed to, for example, store the S parameter estimations and uncertainties for VNA analysis in general. So now that we know sort of a bit more about machine readability, the question is, what would be the big difference between current calibration certificates and digital calibration certificates? And for that, I decided to break it down in what was, what is, and what will be. So what was a paper calibration certificate. That's it. We hopefully all of us understand what that means. What is currently happening, and people are saying we already have a digital certificate, is a PDF. We're saying, okay, that's a digitized certificate, not a digitalized certificate. And in most NMIs or calibration laboratories, they already have a PDF, and that's great. But a current PDF certificate is only a paperless certificate. So don't be confused when you think if it's a PDF, it's already digital. No, it's digitized, and it's just basically a paperless calibration certificate providing the same amount of information of calibration certificates from the past. To that point, most of them, or some, are directly scanned versions of the paper certificates. So, but in the future, what we're calling digital calibration certificates, it's a little bit more than that. And for that, I'll try to start with very simple examples that we already have in Metas. As I said, a digitalized version of certificate should provide extended services, should provide something more than what the old certificates were providing. And for that, I use this example that is in the Sense Lab project process that we have in Metas. For that, I'll explain a little bit about what Sense Lab is we are calibrating the sensors for motion and presence. And for that, we are following a very specific norm that is called Sense Norm that deals with specific values that are not just enough to communicate that the sensor has been evaluated and has passed with these results, because those results and the characterization based on those results is used afterwards, not just by whoever bought the sensor, but also by whoever's going to use the sensor for one specific reason. These sensors are movement sensors, for example, to turn on the light and stuff like that. So in order for us to adapt to this customer, we create this DCC as a customer-centric DCC that provides the measurement data of the motion sensors like anyone would do, but in a specific XML format that is following the norm that already exists. So in this case, it's very useful for us because we already know which kind of formatting is needed. So interoperability of that format is not a problem for us because it's already following a norm. But because we are providing not just a digital certificate, but we are also providing the measurement data, we allowed the person receiving the certificate to actually use the certificate on, meaning the results and the information, aka the data and the metadata, comes within embedded in this DCC, allowing us to not just provide a certificate, but a certificate plus additional information. This trusted DCC, as we call it, can be sent directly to the sensor manufacturer as part of the final service. But afterwards, the manufacturer can provide these results, so the DCC, to architects or light planners to use the extended information from the XML format that comes for perfect interoperability from Sense Norm, because there are specific software that need that specific formatting in order to provide the designing of lights. So the good thing is that when they buy a DCC from us, they already buy in additional information that would be useful for the customers that are buying the actual sensors. And that is more than what is just coming from a normal or a current paperless certificate. That's why we're already in the digital calibration certificate business, but as a very simple initial example. The good thing is because the format is already set, all of this can happen without any human interaction required. So by metadata describing the data and by the XML format following the norm, we can present results that are directly correlated and used in other software, being trusted because it comes directly from Metas. So that's neat. Now, I've been saying metadata for a while. I've been asking Daniel why now Modcom is proposing a metadata model, not just a data model. So then I put also a frequently asked questions slide about metadata for everyone to hopefully follow along. What do we mean when we mean metadata? Metadata can simply be described as data about data. So basically, it's not just the data that could be a result, but it's also providing a context of that data in itself. So examples or easy examples of metadata, for example, if we focus on a DCC, would be the name of the laboratory that is providing this DCC, the tested device that is directly responsible for the results of the DCC, and specific types of details, such as the unit of measurement. So let's go, for example, in the easy example of name of laboratory. How would that look for a machine? Would look something like this. That is just basically a JSON formatted way of describing metas, providing information such as the address and the country and the postcode. So this is an example of metadata. When I say name of laboratory, I'm providing metadata about my DCC. So hopefully this covers enough. What do I mean? What I mean about metadata? It's not just the data, it's data providing context to that data. So finally, we can start talking about what I said we already doing in Metas. That is, we have developed a PDF A3 solution for DCCs. meaning we know we are in a transitional period between paperless and digital implying everything, as Daniel said, in the future, machine-to-machine communication and everything else. But for the times being, we need to be customer-centric. We need to know what is actually needed for the transition to be easy for the customers, but also easy for the NMIs and also easy for any other calibration laboratory that is going to use this new tool or this new extended service possibility that comes within a DCC. So for that, we've chosen a PDF-A level 3 because A in the PDF-A formatting is directly for archiving. So with that, we are covering the common requirement 1 that we've just described. Then PDF-A level 1 basically allows you to, because it is set to create our archiving files, it sets all the fonts and all the images that come in the PDF embedded in the PDF, but that's just level 1, so that wouldn't be enough for us. Level 2 allows you also to embed documents within the PDF, so it would be a PDF that includes inside of the PDF many PDFs. Almost there. Level 3 actually allows us to provide any type of arbitrary files to also be embedded. And finally, we can actually set what I mentioned as common requirements 5, the possibility, not must, but might be able to include additional information. So for the example that I just gave you for SenseLab, it would look like this. Inside the PDF, you would have the document in XML that is actually directly the result from the document, but in the specific format that SenseNorm provides for, and additional information of the attachment, because that is minimum requirement for our IT security aspects. So hopefully that's clear, that it's clear for us for the digital calibration certificate in Metas, we need to provide a PDF-A level 3 because it allows us to have the most dynamic solution for customer-centric services in this current transitional period, while many other aspects such as the DSI or other specific formatting that is still not clear because it has no specific norm, like SenseNorm has already a clear norm, are in develop. So while things are developing, we need to be able to provide new services during this transition, and this has been our solution. So the question now is, which data must be machine readable in a DCC? For that, we obviously focus, so TCIM 1448 is saying a DCC must be machine readable. This is the common requirement 2, as I mentioned. And what I said is, as minimum, we believe we need to follow what a common requirement for a report should be from ISO 17025. Here, as you can see, we have the title, the name and the address of the laboratory, the location. So here we are basically following ISO 17025 version from 2017. The idea is if we provide at least this minimum information as machine readable, so we've chosen a specific JSON format that allows us to embed all this metadata in the PDF without any problem, is enough for us to say our DCC is machine readable. So then we are only lacking a couple of other different details regarding traceability and security, and then we've covered everything that we've described as common requirements. For traceability, basically considering requirement 3 and 4, as I described, we have that already covered in the paper certificate. So the idea, if it's Metas is providing the certificate now in a digital way, everything comes within the current certificate. It's already in the digital certificates because it's an NMI, so everything should be covered there. And then the last part, integrity, authenticity, and confidentiality. So the IT requirements for the cells, we cover it like this. So confidentiality, integrity, and availability for both data and the service in itself. So these are the solutions that we provide for now. Basically, we digitally sign the document, allowing the document not to be changed without noticing, basically providing integrity and authenticity, not just in the DCC, but also in all the content that is inside. And for the document transmission in itself, if confidentiality is needed, right now we have a current infrastructure for customers to download the signed documents only after login. But if needed a higher confidentiality level, there's always the potential public key infrastructure solution. But that would be only dependent if the customer is asking to be the only one being able to read the document. And for that is an easy public key, private key infrastructure that can be developed. Then, as I said, for the last part is, what about the embedded files? All the embedded files have a specific size, and from that size and from that hashed document, we have a list of they call it digital fingerprints of each of the documents, allowing us, this is just basically a cryptographic checksum, allowing us to include that checksum as part of the metadata of the DCC for all the files, allowing us to be sure that we are providing authenticity and integrity for all additional documents that are actually embedded in the DCC. So that's basically how we've covered all these common requirements. Now, how does this look? As I showed before, is the report keeps being a simple report or a complete digital calibration certificate as known, but it includes metadata report. So it includes all the metadata based on, as I said, data about the whatever minimum common requirements that ISO 17 is requiring. We also include the data or the raw data, the specific formatting that is required by the norm. And of course, we include a TXT that attaches all the hashes. So basically all the digital fingerprints or everything that is come along. So at any point, the customer can make sure that nothing has been changed, or if something has been changed, it shouldn't be used. And for that, we've developed basically a very simple formatting formatting platform that provides us these DCCs with the embedded files that allows us all the files containing information and additional information to be embedded in the document, as you can see here. And then all the checksums, basically, as I said, guarantee all the integrity of the files within the DCC. And for that, the last part now, because I think we're going well in time, is the three examples that I presented here. The first one is the Sense Lab, as I described, following the CERN's norm with machine readable solution for present sensors. The second one is the VNA, so basically the vector network analysis format that is already well known as part of the software, come with embedded files that are in the certificate. So with VNA tool, the software that everyone uses, you can directly open the document from the DCC, making sure that it's a trust document that you're opening. And then the third one is something that is ongoing and we're trying in the laboratory of acoustics. So it's not specific format, it's not specific. What we're trying to define is what other kind of additional information can we provide for a calibration. We're basically starting with sensitivity values, but the question is, and for reports, what else can we provide specifically, not just as normal customers or calibration labs as customers, but also as other NMIs? Because once we define that, we're basically defining the path towards a digital key comparison in the future. So those are the examples. I'll just go into detail for each of one. As I said, Sense Lab is using this API that we've done for the DCC, providing embedded standard documents that are following the Sense norm in the PDF A level 3. And this allows us to deliver the measurement results and a perfect machine readable form, basically achieving the interoperability needed for the customer, not just as the sensor's manufacturer, but also whoever uses the sensor afterwards. So the idea is basically by including this document following this Sense norm that is already standardized, we have this type of documents that are needed for architects and light planners already in the format that is needed, but also trusted because it comes within the known DCC from the motion sensor. The second one, as I said, is VNA. The idea is this document comes within init. So then while opening the document in the VNA tool, you have access to all the S parameters, trusting that they are coming from the certificate. So no one has modified it. So the customer can trust that what they bought is not just the calibration certificate, but the calibration certificate plus additional information that they can use for additional evaluation or for their own quality aspects. And then the third one, as I said, is right now we are currently only adding aspects that we believe other calibration labs needs. So sensitivity results from the results that are already happening, but potentially we would like to make sure that we can embed enough information, meaning data and metadata, to allow a complete comparison. And it's funny because Daniel said that in order to manage good comparisons, they're trying to reduce redundancy. I agree, we should reduce redundancy, but also we should add any other information, meaning data or metadata, needed to make the comparison easier, or to allow us not just to compare results, but clear paths or parts of the procedures. And for that, basically, what we are proposing, but this is in the future, is if we, for example, are a pilot in a key comparison, we can provide a public key infrastructure. So basically, with a private key and a public key that would include, instead of a digital certificate, would be a report as part of the key comparison. And in this case, basically, if we're just doing a digital certificate, it would be for a customer in industry. If we're just doing something for a calibration lab, it would be directly for a calibration lab. So it would have additional information like the sensitivity results. And then for a potential digital key comparison, we would just directly communicate it to NMI. We've been in talks with Spain. Still not clear, is everything on the go, but they told me we have a little bit more time, so I decided we need to include this information for people to see where we are and where we're going. And basically, as a potential example of what a digital key comparison would mean is we include not just the results, but the methods, the ways, the models, and every other standard that we need to explain. So any other NMI not just gets the information, the results from the other NMI, but additional information that describe how the results have come up with. And basically, that's it. So as a short conclusion of points, I would say that for us, we need to start with common requirements for the DCC. And of course, this is an ongoing discussion in a general aspect. But as part of TCI M4D48, we would like to focus more in field-oriented aspects. And for that, they might be extended common requirements, or we might use the common requirements that we have, because might be enough for us to digitalize certificates as they are. Then the second aspect is this solution as presented is just a solution. It doesn't mean it's the solution that you need to use. Basically, we believe that by standardizing common requirements, any institution can develop their own solution as long as the common requirements are followed, and allowing us to work within this transitional period from the paperless to the fully digital certificates. Now, the examples that I've shown, I hope, prove versatility by proving that we have two main aspects in our approach. We are customer-centric, that is, if the customer needs it, we do the development in order to make sure that additional services can be provided for customers that need it. But the PDFA level approach, PDFA level 3 approach is very helpful because it's a very dynamic tool that allows us to have different solutions with the same different solutions for specific customers with the same application of DCC. And then, of course, the further work to come, and here, of course, I'll mention that the first thing that we need to do is to make sure that the machine-to-machine communication needs to focus on BIPM key comparison database. And right now, the key comparison database has provided a new API. So it's great that we have an API and they have an API. We need to make sure that they interpret themselves well towards interoperability. The second one is to actually include DSI as soon as agreed, how we should make sure that data units and SI should be presented in a digital frame. And of course, any other additional information that might be needed, for example, any specific formatting for any specific technical committee. So for that, this is what we are suggesting to start working on next year, still in TCI M4D48, but with direct collaboration with the technical committees and the European Metrology networks as part of Euramet. So thank you. I hope no one got bored, and there's still time for communication and having a talk.
Thank you very much, Federico Grasso, for your presentation. Let's see if we have some questions in the chat.
Cool.
Please close your microphone if you are not going to ask something. If you are going to ask something, go ahead right now. Thank you. Okay, so I'm going to read some questions here from my side. From your point of view, how do you think we can solve the area of opportunity where private companies already use meta languages like XML for communication of their systems? Do they have to couple with us, or should we create compatibility tools?
Basically, this is a very good question. That is, the example that I show for SenseLab is the greatest example. The companies decide their own format, so we provide the same format in order to avoid compatibility tools. Because the moment we start using middleware to adapt stuff, we create new problems. So we allow new services while creating new sources of problems. So what we believe is, in order to achieve the best interoperability possible. We just need to have one standard interface to provide the service, like the PDFA level 3, but to follow customer-centric options, like, for example, what you're saying, if the private sector has already defined a specific formatting that they need to use, we provide that embedded, making it trusted because it's part of our DCC. So I hope that's clear, Aldo.
Yeah, thank you very much. Francisco says, if the information of a DCC is inside of a PDF, what kind of readers do we need to take advantage of these files?
And this is the beauty about it. So it's great. Thank you, Francisco, for that question. This can be, the example that I show is just open with a normal Acrobat reader, but that's for a human reader of the information inside. For a machine-to-machine communication, because it is inside, with an API, you can basically query the information from within the PDF automatically with their own API. So for example, if a customer wants that additional information in order to be, let's say the most simple additional information, until when the certificate is valid, with their own API, they just pull that information in from the DCC and then just can put it in their own databases. So the cool thing, as I said, is because the information is in the PDF, you can use an XMP format, that is a metadata format that is compatible with PDF, but you don't need to. You just need to have the information inside the PDF, and then the customer can do it with their own machine-to-machine communication because it's already machine readable. So I hope, Francisco, that's clear.
Thank you for your answer. I don't know who write this, is a guest in the title. Thanks, Federico. Are you thinking in GNU license for this standard? I think that Microsoft is not a standard for metrology. I think this new standard should be able to software development in any operative system.
I completely agree, and that's why I'm saying our PDFA level 3 solution is just a solution. As long as you follow common requirements, you don't need a specific standard for a DCC. You just need understandable or interoperable information in the DCC. Now, that question about DSI, that's something that we're still discussing, as you've seen with Daniel. As soon as that is clear, our solution just basically embeds that DSI format as well, and then there's no problem. I hope that's clear, Gabriel. But I think you said you're from Córdoba in Argentina, so saludos.
Thank you. Very well. Jose Armando Lopez Ellis says, JSON only handles UTF-8 encoding, isn't it? This is a limitation for JSON?
Of course, but as I said, remember, we are just saying that the metadata in JSON is the minimum common requirement, common information from a certificate. So it's just the title, the address, all that list that I gave you from ISO 17025. The beauty about this solution is that that JSON formatted information is in that format because it works perfectly with UTF-8. If you want additional stuff in a different format or in a specific XML schema, you can also embed that, continuing having integrity within the PDF level 3. So yes, JSON is limited, but it's perfect for what we're using it. And our solution allows us to use as many needed formats for the machine readability for all the different aspects. I hope that's clear, Jose.
Perfect. This question is, I think I can make this question for both of you, Daniel and Federico. I don't know, I prefer if you, Federico, answer first and then Daniel. As Chris Paredes said, it has been considered that some small errors arise when machines represent real numbers as double variables. Is the precision of floating point arithmetic fit for our current and future purposes?
Daniel, you're the DSI.
Okay, if you like, I can start. If you think of data today and the calibration certificates having typically, I would say, 6 or 7 significant digits. In some domains, you even have only 4 digits. Then you have the double formats, double precision having 16 digits. So I would say the arithmetic errors from converting this 4 digit values into 16 digits is very small. So it's the natural rounding error you would have with any calculation, even with an Excel, for example. So I don't see it critical. It's more critical for the domains where you have numbers like nanosecond values referring to a scale of seconds where the numbers are very long and where double is no more sufficient. Then you need to find different means. So even ICT technology is not providing universal solutions for that.
Very, very well. Thank you, Daniel. Do you have a comment, Federico, for this part?
I completely agree. What I would just add is that as soon as we are certain about what DSI should look like, it will be very easy to implement in our solution. So we are looking forward to know more and more from the DSI working group in the CIPM.
Perfect.
Can I ask a question to Federico as well?
Yes, go
Sorry,
ahead.
I cannot
Thank
use
you.
the chat.
Yes.
So thanks also, Federico. I like your presentation. I've seen it before, and it's very clear about the definitions and what we are talking about. At the end, what I saw, you mentioned that Metas is providing private and public keys to other NMIs stakeholders. I wanted to ask, is this
potential thing for key comparisons? That's not happening right now. It's a suggestion.
Yeah. No, so independent from key comparison, does it mean you thinking of becoming a key certification agency? Like today, countries have agencies providing the key cards and the private and public keys to any customers. Is this the idea? Or?
No. That's not the idea. That's why when I mentioned confidentiality as one of the aspects for IT security of the common requirements, I said that if there's a case of a customer requiring a public key infrastructure, they should tell us which one. Because the moment that we start providing public infrastructure for all the customers, it's a different business that we need to deal with, and that we want to avoid. So no, that's not the goal.
Okay, thanks for making this clear. Yeah, good.
Thank you both for these interesting comments. And we thank Mr. Federico Grasso for his presentation and for answering every question. Finally, I give the floor to Mr. Carlos Galvan, leader of the Digital Calibration Certificate Working Group, to make some final remarks and close the event. Please, Mr. Carlos Galvan, go ahead with your final remarks.
Thank you very much, Aldo. And thanks to all speakers for this kind presentation and also for the discussion. I think that is very useful for understanding the problematic that we have to development, to design a DCC. Before to close this session, I would like to show you some ideas that I have in my mind about these DCC topics. And I think that this is important for the laboratories that are thinking to start the development of DCC inside of the laboratories and institutions. It can be considered. I just want to say, for example, actually, for example, most of the institutes uses different tools to design or to generate the certificates. I mean, they can use word processors or spreadsheets in order to make the calculations and in order to generate the printed certificate, or also the PDF, like our speaker mentioned in the working. So, but for the, like I say, the PDF also can be handled. But we need to think, for example, actual certificates, who is it for? I mean, when we think or when we make a certificate, we think that the who is going to be these persons, humans. I mean, that's why we usually include some task description, some graphics, some images, in order to show to the people how is currently doing the calibration or how looks the results. So until now, that is the uses or the recipients for the calibration certificates. And also, for what we use this calibration information in certificates, for example, for corrections, right? The information in certificates can be, for example, readings, the difference between the standard and also the error. Of course, the people needs to take this information and make the corrections and make the actions that we need to do is make the corrections in order to obtain a correct reading and use the information that is included in the certificate. For example, in the case of uncertainty, it's important to take the value in order to estimate the next levels in uncertainty. I mean, when I use a standard, when we use a gauge, we use a calibration procedure, and then we are already another uncertainty contribution. So we need this information in order to have. Until now, we read the document, we read the PDF, we read the printed document and obtain this value and then transfer to our system, to our software, in order to calculate the most values. But like the new proposal for the DCC is data exchange. It's not only thinking and reading this information by a person, but also by machines. I mean, I need to transfer all this information that I have to the machines, to the production floor, etc. I mean, use this information because it's not only to see the results, to have the paper, but also use the results obtained in calibration certificate. So that's important that this exchange information is only not for person, but only not for machine, but also, for example, a quality digital system. I mean, a system that can give some information about the status of the quality system, and also a different system that use this information. So the intention of this data exchange is this information can be read not only for machine, but also for another system and also for humans. And one thing is important that we are mentioning in different meetings about the DCC and also in the working group at the SIM is that with the current certificates, is all data entry manually. Maybe in some institutions, they don't have this step that mentioned our speaker, especially Francisco, that say about what is digital and digitalized. I mean, it's important to have the information in digitalized format. I mean, that this information can be used and be shared by other systems. So, but the problem is okay, and the question arises: is the information for certificates digitalized? We need to analyze in our system. I mean, every institute, every laboratory has different levels of digitalized information. Some information can be just manual entry, but also many or inside the laboratories have some automation task. So they have already obtained digitalized information. So with this in mind, there are some considerations that we need to think about to develop the new DCC or the new digital calibration certificate. So now a DCC not is only for person, it's also for machines, it's also for systems, and also for instruments. I mean, an instrument can, if it has an electronic interface, also can read it, and then read all the information containing the calibration certificate, and also maybe for auto-compensate and make all the correction that is needed with no human intervention, for example. So, and we need to think about what information is needed like I mentioned, actual certificates are designed for people. So maybe some information is not necessary to be included in the digital version because it's not being interpreted by a machine or by another instrument. Of course, you can include if we can read it by the human, by persons, but also we need to concentrate in the information that can be used for no human entities like instruments, machines, computers, and as we see. And another consideration that we need to think is what about lab automation? Is necessary to have an automated lab to generate the digital calibration certificates? And I think the answer is not. It's not necessary. We can, of course, it will be important. It will be useful in order to have all the digitalized information, but it's not necessary. We can start to generate our digital calibration certificates a step ahead of this. I mean, we can go using our actual ways of generating the calibration certificates, but thinking in a digitalized form. I mean, XML format or the format that was established or was selected by the laboratory, but it's not necessary to put. It's useful, but it's not necessary. Okay, so thank you very much. I just want to close with this thing, with these considerations. And I don't know if there is a question about us. It's a comment. We have time to close the session, but it's time maybe for one or two comments or questions. I don't know if Federico and Daniel want to add something about the talk, about the speaks, about the DCC.
If it's okay, I can add something. I was gonna write it as a comment to you. I thank you for the presentation. I completely agree that we need to start thinking, who is this for? And I completely agree with the final remark. I believe that we can start right now with DCCs like we're doing in Metas, just by focusing on specific requirements and slowly advancing. And if automation comes in the labs and if new technologies comes, we can adapt eventually. But right now, we can do it right now. And my suggestion to all NMIs that had asked me about it is you do it customer-centric or focus on what the customer needs, is faster and easier for you to find which specific fields you should start with. So that's
exactly.
Just my...
Thank you very much, Federico. You're right. Yes, Daniel, go ahead.
Yeah, thank you. So yeah, I like to add to that. The DCC full machine readable with all functions for interoperability will not be ready tomorrow, but we will have certain years of transition period where digital formats are used in parallel to ongoing use of course, the PDF documents to a certain account. We should be clear, it's a big step. Maybe today we are beginning just thinking about making things machine readable, which is already a big step, as you can see. And for many years, we will work on that DCC development towards this machine usable, machine interpretable, and AI ready, just as a keyword here, documents. And then it's absolutely correct to say, when it's ready for the future, then it's the time to get into automation and explore further benefits. But for today, the first and big benefit is to have the data machine readable, even if it's still not interoperable to a certain extent.
Exactly. Thank you very much, Daniel. I will appreciate your participation. I will appreciate your time because I know that we had a big difference time zone. So thank you for your effort to participate in this. I hope to see you soon. Thank you. Go ahead, Aldo.
Thank you, Carlos. As I said at the beginning of the day, a brief poll will appear in the chat. I invite you to answer the questions. I think it already is there in the chat. We invite you to visit our webpage, where you will find more information and also previews, presentations, and recordings of past events. Thank you all, and especially Daniel and Federico, for sure Carlos, for your presentations, and for sharing your knowledge of these interesting topics. Finally, I invite you all to turn your cameras on so we can make a capture of the screen.
Yes, please turn on your cameras. We are 100. Then please cross your fingers in order to the platform support. But we will try to take a picture with many of you. Please, I hope I'm waiting for you. And please smile. And get your hair done. And say whiskey or DCC or something larger in order to have the more enough. Just a moment, please. Wait a second. Okay. Wait a moment, because we are many people here. Another one. Okay, thank you very much.
Perfect. Thank you for your participation, and see you the next M4TD day.
Thank you.
And please don't forget to fill the evaluation. Thank you very much for our speakers. Very good. No, thank you.
Thank you.
Thank you very much.
Thank you.
Yes. Have a nice day. Bye-bye.
Thank you.